Hello, everyone, and welcome to our lesson on the fundamentals of programming in R. We're going to use this moving forward from now on in an inquiry-based way, where we'll learn basic commands in R towards our way of building towards a larger data set from the encode download, and then analyzing the output files of those. So we'll start off slow and build up as we go and mention in little bits of fundamentals here and there and go along. So from the last video, you should have a directory that looks something like this, where you've cloned the directory, and we had you install all these programs and have by now, although we're not actually going to really use them. In the last lecture, we looked at how to use install packages in our first R command. For today's lesson, you'll need this data file here. We're going to analyze a file that we will make eventually for our new data set, but using last year's class's output file of each DNA binding protein, how many peaks it had in the total coverage in the genome. So you'll have all those files and you'll put them in data here. And so gen code annotations, etc. We'll use all of these files, and essentially we're now kind of moved in to our directory. And if you're doing this at home, you have cloned it in your own directory path. And again, it's always good to make sure you're going to where you want to be with your working directory. So let's look at our first chunk of code. But first, what is a chunk? You can make a new chunk in the code button up here. You can do insert chunk. And this is where you'll start to write your R code in here. We already pre-made these chunks. And usually you can write text to say what you're doing. And in this video, we'll go over more of the concepts, and you can read back through some of the individual things you're interested in. So for now, I'm going to delete that. And so let's read in our first file. We have all of our functions loaded, even though we're actually not going to use them today. So to run a line, we highlight it and then hit Control Enter. And now you see we have something up here called file. Let's take a look at it. Okay, so this looks complicated. It won't be later, but it isn't the most user-friendly output at first. So we can use the Unix, remember we used the head command to look at a file. So let's just take a look at this file and see what it is. First, I should note what we just did is that we made a variable file. And so what it's going to do is read CSV is an R command to read a CSV comma separated file. And that's in your data folder here. So you're saying read CSV, here's the file path. And now take all of that information and put it into the object file. And so this object will retain all of the information from this file so we can go in and play with it. So let's take a look at that with head to take just a quick peek at it. And we can see down here that we have a Tibble. I left a link here for what a Tibble is, and we'll talk more about that. But essentially for now, you can think of it as kind of like an Excel sheet where you can have columns that are characters, columns that are numbers, and we'll get into more and more of that as we go. But you can already start to see that here, that's a Tibble, meaning it's flexible of what you can put in there. It's, and you can see that the first one is character, for the CHR is character. And double means it's a number or a floating point number. And so it's just telling the rows and columns and what type of information is in each one. It's sort of stored in there. You can see the same thing here where we see DBP is the first column. And here we can see that it's a character for CHR. Here we see number, and you can kind of match them up as you go. So okay, so we've taken a look at a file, and there's other ways to look at files in R besides just head, and we'll go in through some of those more, but one useful one, I left Table in here, you can play with it yourself. The it's got marked down for what to do there. But let's run a summary here. And what's really nice about R is its statistical basis, that just by running summary of the file, we can see, so summary is an R command, and what we get is its length is 161, meaning there's 161 DNA binding proteins. The minimum number of peaks is 263, the average is 5,000, the max is 60,000. The same for length here. So that's kind of interesting. We can already do that right away and get some information. Okay, so moving on now, we'll close this up. And oh, by the way, you can also view this if you double click on it. You can view it in here as well. You can see that the DBP is the name of the thing. It's 161 long. The next column is number of peaks, total peak length. Okay, so now let's play with that data. So we just saw that. So now we can use filter. So again, in R, whenever you have this arrow, you're saying take the information from the right side of this arrow and put it into the object I'm calling on the left side of the arrow here. So we're going to look for gene X. So we're going to find the gene that has the most number of peaks. So we saw here that in our summary that the max was 60,035. So let's just see who's bigger than 60,000 here. So we'll call the R command filter. And what filter wants, and you can check the manual page as we've shown before, again, just by running that, and you get to here, we want to look at it in the base R, look at it in the dplyr. It's a subset data, and basically what it does is concatenates a vector into after it's converted them to characters. So you can take a look more into that as you go, but filter will then ask for what file where you're going to look in, and that's what we're going to look in is the file we made up above here, file, and then we're going to index file. And so this is a new thing we've seen now, is this cache sign. What that means is I want to index this file into the column named number of peaks. And we can do that with rows and other things, and we'll go over that later. And I want it to be greater than 60,000. So GeneX is going to say, filter is going to say, give me only any data that has the number of peaks greater than 60,000. And again, this is indexing. It's good. We'll do a lot of this and talk more about it, but we're just starting out nice and easy here for now. Okay, so let's run this. And we see now we have gene X here. So let's close file and look at gene X. So we see the DBP is the first column, it's a character, and it's EGFP CEBBP. It's a DNA binding protein, doesn't really matter for now. And then it has a number of peaks of 60,035. So that was that max we saw down here. And the total peak length covered by this, all the peaks. Okay, so great. So we can filter and pick out a gene and just with two commands, get the summary statistics and then pull out the median gene or the max gene or the minimum gene. And then you can do that very quickly with filter shown here. Okay, so we can do the same thing. Let's find the smallest gene. We don't need to rerun that. It's identical. It's identical logic. Again, you can do math inside here or manipulate this column. And this is just indexing, saying I want this column inside file and I want everything less than 264. Okay, so now let's say you want a gene name. Now this is a little bit trickier, but not too bad. And we can see the same sort of structure here. So we're going to make an object gene pull2. We're going to call up filter to go through the file data here. And then we want where DBP column dead set to equal to pull R2A. And so that's a gene, it's polymerase 2, the gene that transcribes all genes, or most mRNAs. And we'll go look for its data. Let's say you were interested in your favorite gene in a data set. This is how you can do it. So if we run that, We'll go here and see what we get. So gene pull 2, pull R2A, number of peaks, and so we just pulled out that one row. Okay, so let's say you wanted to add a new column. And so what you can do in indexing here is with this index is say, I want in file, I want to make a new column. I'm going to make a new index here. And what I'm going to put into it with the arrow is just the text what, and we'll see what happens here. So file currently looks like this with 3 columns, DBP, number of peaks, total peak length. Now we're going to look at it and see what happens. Well, there we go. We got a new column that's pretty useless. It's a character 1 through 161, and we just got a new column of what. And you can also sort in here as well, and we'll go through that as we get to it. Okay. So now that if you wanted to remove that column, you could use a different type of indexing with the square brackets, where you're saying in file, remove column 4. So the -4 here. This is another index into file. It's going to go into that index into column 4 and print that into file remove call. That doesn't have this column anymore. Okay, so we can already have a quick way to make a plot, a histogram. We'll go over that. It's just going to tell you the frequency of number of something. So in this case, let's look at the number of peaks. What is the frequency that something has 60,000? Well, we know that's 1, but what's the frequency if something has like 10? Well, we can plot all that out with hist, which is going to make a histogram for us. And we're going to tell hist to plot just this column, number of peaks, because we only need one column of data for a histogram, where the y-axis will be the frequency and the x-axis will be the number of peaks. And breaks, you can add different things, and we'll do more of this later. But you can then, with a comma, start doing other things like adding the breaks to be 100. This is how big the bins will be when it's plotted, and you can play around with this. But let's run it real quick. So boom, we can see here a histogram. We have the one out here at 60,000, and we can see like there's sort of the vast majority are under 10,000, and we saw in our thing here that around 5,000 was the median. So the median of the data is somewhere in here, and it's plotted this, and we'll work as we go on how to make plots nicer and nicer, but you can export them right away as you go and have your first R plot. You can also plot 2 columns against each other. So just a simple XY plot with the plot command here. And so let's try that. Plot X, Y. So sorry, we're going to plot, and what plot wants to know is what X is and what Y is. And so we're saying X is equal to the file index number of peaks. So the number of peaks will be on the X-axis. Y equals the file and index into total peak length, and that'll be the Y-axis. Okay, let's see what that looks like. Oh, interesting. So we have a new plot, and we can see that that the number of peaks, the more peaks you have, the more coverage of the genome you have. You might expect this to be somewhat linear, and we'll go through later and figure out ways to see if that was statistically significantly linear or not, using a lot of the handy tools built into R. Okay, so now let's say we're interested in a subset of data, and we want to look for not only poll R2A, but poll R2B or sub5H. And really what we're going to do here is just do this by hand, but later we could put a file in here that has a ton of names in it. And so it'll go look for all those. So what we're doing here with the arrow is we're making an object called genes. And C is just like a way to say concatenate or paste these things together, print this into genes. And so what it'll print is poll R2A, poll R2B, and sub5H, and you can go on as long as you have a comma, and you do need quote double quotes for the text here. so that R knows that this is just character basic text. So if we run that, okay, so now we're going to get something called genes. Here we should have, oh, here it is, values. Okay, so all we did is say here, this genes thing is these three sets of characters. And this is going to become interesting when we use grep now to go get these data from the bigger file. Okay, so remember they're in character, and that's important for grep. So let's do that now. So we have an object genes that we can use in filter now to find our favorite gene lists. Okay, so this is a bit complicated. We'll walk through it slow. That we're going to make this thing called gene list, which is eventually we're going to want the data for these three, not just one. We'll do filter as we did above. We'll give it the file object is what to go into. Then the next command for inside of filter will be grep-l. That's very similar to the Unix version we went through in a previous class, class. And grep-l will then look for paste is a new command we're seeing here. It's going to look for what paste outputs, and that's genes, and that's this list here. So that's a bit complicated. So grep's going to say, okay, I'm going to try and match something. What I'm going to try and match is tell me what to match, and you're saying paste genes and match that, and where you're going to look for that is in file dbp. That's where that term will be in the dbp name column. Okay, so you take some time to go through that. We're going fast here just to have a sort of conceptual companion to the written text. Okay, so this we're going to run seems to make sense. Oh no, it's wrong. And the reason is, we won't get too much into this, but grep needs to look for a regular expression. And when it sees a character, it's only going to do the first one. And it'll give you a warning. It didn't give me an error. It gave me a warning here down here. Saying, hey, I think there was more stuff to do, but this is where I stop, is after the first string of characters. And so we'll get into this again much more later, but there's a phenomenon called a language of regular expression, where you can use different characters to specify in a non-character way what to look for. So, and we'll use more of this later. It is a very complicated aspect, but grep is going to need to look in the file in a way where it's looking not at characters, but as a vector of information. Okay, so now we're going to use it the right way, and you'll see the only difference we did here, instead of paste just genes, we're doing inside that command, we're going to add collapse with a pipe. And that means grep can look through all of that string. It can keep going. And you can Google that regular expression. Again, we'll talk about it later, but it's just a way to know that that's how grep has to think. It can't just get a string of characters and deal with it. And then again, it's going to look in the index dbp inside file. Okay, so very similar. Let's step through that again. We're going to make a gene list for our favorite genes, these three here. We'll have filter call up the file of information, and then grep is going to go in and grab those three genes, and it's going to know where to look inside here. And we'll do these more and more, and they'll start to make sense. But for now, I can understand if this seems very obtuse in the way of logic. But let's see what we get. Okay, so now we have gene list. Let's see what we got. Okay, so we got polar2A, polar2B. It's a character. The number of peaks is shown here, and the total peak length. So essentially, it's a 3x3 table. We'll talk about matrices, data frames, Tibbles, and all sorts of that stuff as we go. But for now, the idea is that in one line of code, you can go into a big data file. As long as you know what column that data is in, you can use grep to go grab all the data associated with that term you're interested in. And we'll get into more complex ways of genes being a larger list than just three. later. You can also do some indexing here. But let's introduce, so go over this. This is an interesting error if you want to sort of keep learning about this, but let's keep to the concepts for this video. Another thing we want to introduce is the pipe. We learned about the Unix pipe where you're basically sending information down the road, and that in R looks like this, %, and so what that will do is go to the next command in line. And then you'll see in here, which is sort of what it says, is look in here. It's going to look directly, when you write it this way, it's going to look directly in exactly what you tell it to look in. Okay, so we're kind of really doing the same thing we just did. It's just to introduce the pipe and in for now. So what we can see here is we're going to look in file, and we're going to take what's in file and push it to filter, and we're going to filter the file index DBP in a list. Okay, so you can do it this way now. So we grep had a hard time with this character string that we made. But now we can do everything in one go without having to use genes. And so this is going to print these characters, again, with the double quotes saying that they're character. And so filter is going to go into this index and only take out things that are in these with these names. Okay, so let's try that. So it should be identical to the previous gene list we just looked at. And we have exactly what we had before. Okay, so now we know how to sort of select data from a file. Again, I know that we went over that fast. There's text to help you understand what's going on here, and take your time with this. And we're just going over this quickly to get this sort of basic concepts. I'm not going to do this, but it is important to know that this data is long. So if we look at file here, this is a very long file. And typically in what we're going to do, we're going to be looking in long files. But sometimes you want to turn a long file into a wide file. So imagine turning the rows into columns and vice versa. There's ways to do that. There's some markdown here for you to look through if you're interested. Okay. So now let's play with the data inside the object file. Okay, so if we head file again, just to refresh ourselves, we have these three columns, DNA binding protein, number of peaks, total peak length, and new column. That's because we used, sorry, we should have used file no call, but it doesn't matter for now. That column was removed in that one. We're introducing the pipe again here. And what we're going to do, and this is a good habit to get in, so it's easier to read for other people, is to do something, pipe it, do something, pipe it, and then do something else. So what we're doing here is we're introducing mutate. This is excellent. This is a really powerful R command. And what is able to do is sort of index in and then do things inside of a file. It can do a lot of tricky things, and we'll start using more complex versions of it. But this is just a basic example of it. If you're interested, you can, again, always type question mutate in your console, and it'll find it for you and tell you all about it. Okay, so what we're doing here again is we're going to make a new file, and we're going to look inside file. We're going to call it up, and then we're going to pipe that to mutate, this new command we're learning. And what mutate will do is it'll make new columns for you. So it'll operate on one column and then make another column, or it'll do it on the column you tell it to do it on. And that's what we're going to do this time, is we're going to call this thing we've been calling total peak length, is we're going to call it length in million. So we're going to just change the column name essentially, but we're going to operate on total peak length here. So we're going to say this new column name is going to be length million. We're going to write over the old column, and we're going to have that new column equal to the file indexed at total peak length divided by 1 million. So now that'll shrink these big numbers down, and we can look at how many million base pairs are covered instead of in such a long string. And then we're going to pipe that to head a new file. We're actually not going to do that. That's just an example of how you could keep pushing information along. Okay, so let's see what we get with this. Okay, so now we have new file. Let's take a look at new file. Let's do it this way. And so now what we can see is I apologize, we made a new column and identified this new column to be length million. And that's kind of what's nice about Mutate is you can go inside of a column like peak length here, do some operation and print it out as the next column in the pre-existing table file that we had made. And now we've renamed that to new file to keep track. And it's good to rename things so you don't keep re-overwriting these variables here in your global environment. Okay, so cool. So now we figured out how to go into data and now change it and make new columns. Let's move to something new here. This is going to look very scary, but this is where we're going to end. And take your time going over it. It's these things will become better and better. It takes time, so it's perfectly reasonable if this is very confusing. We're going to make new file 3 now, and we just made new file 2, which has, so that's a good way of nomenclature is to sort of keep making the numbers of the files go up. So I'm going to run this just so we have it, because it's going to call for it. Okay, so I just made new file 2, which is the same thing we were just looking at here, where we have this new column, what, and does not have the length in million. Okay, so what we just made is the previous file, and now new file 2 is just taking out that millions column, and you can go over that. It's not that important. Okay, so new file 3 is going to be made from new file 2, which is kind of like our original file essentially. And then we're going to pipe that to Mutate. So Mutate likes to go in and make a new column. So this, we're going to call it fun call. And we're going to say it's equal to, and now we're introducing if else. Okay, so now we're starting to think in logic here with the data where we can ask several things to happen. So now let's say we wanted to organize these this file into DNA binding proteins that have a small number of peaks, medium number of peaks, and a large number of peaks. And now we're in millions. Okay, sorry. So we're going to say which guys have small peak lengths, medium, and large. Okay, so let's walk through this and then we'll print it and then we're done. Okay, so this Mutate's going to make and call up an if-else command. It's going to be the first thing what it's going to do in this new column. And so we'll go into new file 2, total peak length. We've looked at that before. It's down here. Now it's in millions of bases. So they're small if they're less than 1 million. And we've seen that sort of operation before we index and sort on something or tell it to give you more or less of a value. So small will be less than 1 million. Now we can just with a comma go to the next if else and say if it's less than 30, then it's medium. And that's really using the same thing we just did here. And you can make many, many, many more if else's if you wanted to. And what's also cool is that you can just have return another. So we made one argument followed by a comma, then another argument followed by a comma. Here, then this comma is saying everything else is large. So that's really handy that you can specify 2 ranges and then it knows what to find in the middle. And so let's try this and see what we get. So we're going to get new file 3 here. And now we have this fun call in here, which tells us which DNA binding protein has a small number of space covered by its peaks, medium space, or large space in millions. So let's use our hist function again. And apologize, that is a little, we went over that a little fast, but everything you need to know is in here. And check out if else in the manual pages as well. Okay, so let's see what we just did with histogram of new file 3. Okay, so new file 3 has many different columns and it just plotted all of them. So we'll get into how to plot the column we're interested in, but really it's this total peak length. We could index into this file here and do hist new file and index into fun call, and R will pop up those things for you to populate them quicker. And let's see what we get now. Oh, right. We can't make a histogram of 3 different character strings, but we can. I think I'll leave it there so we don't get any more confused. But basically, when you run hist on this new file, we will see the frequencies in fun call. Let me zoom in on this here if I can. So if we zoom in here, we did get what we were looking for when it made the histogram, it plotted the frequencies in fun column here. And the frequency of large is there's 20 proteins that have large amounts of peak coverage of the genome with their peaks, about 25 with small, and most are medium, as we'd expect. So that's just showing that we did just group those things, and we'll go into this more, but there's a function group by, which will be really useful later, where we can make these attributes in columns and group them by them and plot that way. Okay, so I think that's it. If we look at the sort of the summary, we can see what the total peak length sort of distribution is. That's shown here in this plot. And just that you can get a lot of information really quick to just get a quick survey of your data and what's in there. So with that, feel free to go back through this and we'll go on in the next lesson and start to work towards using bash and R, taking it another step up to start to make a design file to go take data from ENCODE, put it to a pipeline on Fiji, and analyze a ton of data. And until then, code light.